So in example number 2 here, for example, we have water at 20 degrees Celsius, flow in a 30 centimeter wide rectangular channel like this at a depth of 10 centimeters, which is 0.1 meters, and a flow rate of 80,000 centimeter cube per second. Estimate the float number and the Renault number. So here, please be careful because all calculation must be in SI unit. So you need to convert all the 30 centimeters, 10 centimeters, and also 80,000 centimeters cube here. Means that you need to convert how to from the centimeter cube to meter cube and from liter to meter and vice versa. So and then I hope you still remember the representative or the common value for the density of water, which is equal 1000 kilogram per meter cube. The dynamic viscosity of water, which is 0.001 kilogram per meter second. And if you convert this flow rate, it will become 0.08 meter cube per second. Okay, first question, they ask you the Froude number, and this is the equation for the Froude number, velocity over square root gy. And velocity can be found by, from the flow rate here, we divide with the cross-sectional area, and we get it is about 2.67 meter per second. And then we could calculate the value of square root gy. We substitute the gravity and the depth here, and it is equal to 0.99 meter per second. We could calculate the Froude number, and it is equal to 2.697. Because it is more than 1, we could say that this flow is supercritical. And for Renault number, so this is the equation for Renault number. So as you know, in Fluid Mechanics 1 and Fluid Mechanics 2, we also calculated by using fluid number, but the equation is slightly different. Sometimes we use rho Vd over mu, and then when we learn about boundary layer, we use rho Vl over mu. And now in open channel, we use rho V hydraulic radius RH over mu. So, and then I hope you could calculate the hydraulic radius by dividing cross-sectional area and wetted parameter here. You will get 0.06, and then you could calculate the value of Renault number here, and it is 160,200. So we assume it is a turbulent flow. Please bear in mind that the range of laminar and turbulent for open channel is different from the flow in pipes, because in open channel, when the Renault number is less than 500, it is 100% laminar, and if the Renault number is greater than 2000, it is 100%. It is fully turbulent flow. So please remember the equation, and I hope you could know when to use that equation and to differentiate the range of the Renault number. And this is example 3. An earthquake near the Kenai Peninsula of Alaska create a single tidal called tsunami that propagates southward across the Pacific Ocean. If the average ocean depth is 4 kilometers and seawater density is 1025 kilogram per meter cube, estimate the time of arrival of this tsunami in Hilo, Hawaii. Okay, so this question is asking about wave called tsunami. So the idea is simple. Okay, so I will give you all the information. For example, the distance from Kenai to Hilo. So it is around 4,480 kilometers. And here, from the question, it gives the seawater density is slightly higher from the common water. So I think this is a general knowledge. Okay, the density of seawater is slightly higher, which is 1025 kilogram per meter cube. So, and then, as you know, Reynolds number can be used normally in a fluid mechanics, but for open channel, we are using commonly the Froude number. So the Froude number, so this is the equation, velocity over square root gy, but this question asks us the time of arrival. So in this equation here, there are no function of time, but we could replace the value of velocity here with the distance over time, because when the distance divided by time, they will create velocity. So and then we rearrange this equation, and this is multiple symbol. So and then the most important assumption is we assume that at surface, at free surface, okay, the Froude number must be equal to 1. So this is the assumption that commonly used when we use Froude number. And we could calculate that one because the Froude number is equal to 1. Then we could rearrange. We have time and equal to distance over square root gy. We substitute all the values. Okay, the value of y here is simplified. We just average the sea depth, so it is equal to 4,000 meters, and then we get time is equal to 22,615 seconds. Okay, lupa saya nak cakap satu lagi. Nota ataupun jawapan untuk tutorial ini saya tidak akan upload dalam bentuk PDF. Cuma saya akan upload dalam bentuk video. So saya harap pelajar dapat capture, sama ada screen capture atau membuat nota tangan sendiri berdasarkan video yang boleh ditonton di kemudian hari. Boleh ke?
Boleh Doktor.
Okay. So maknanya awak alert nota yang lain saya akan share dalam website. Boleh. Saya berharap nota untuk tutorial ni maknanya ada sikit effort awak menyalin atau sebagainya. Okay, next. For example number 4 here, we have a rectangular channel is 2 meters wide and contains water of 3 meter deep. So if the slope is 0.85 degree and the lining is corrugated metal, estimate the discharge for uniform flow. So first, we imagine the open channel like this. So the width is 2 meters, the depth is 3 meters, and then the idea of corrugated metal means the roughness of that open channel. So we need to seed a table for that roughness. And normally in test or in final or in this tutorial, we give you the value of n. So for corrugated metal, the n is 0.022. And the question asks the discharge for the uniform flow. So the discharge means the value of Q. Okay, so we have actually two choices. One is calculation by using cheesy formula and one with the Manning equation. So in our syllabus, we are focusing on Manning equation. So this is the Manning equation to calculate the flow rate or the discharge. So so the problem here, the R here is actually the hydraulic radius, because as you know, we have a rectangular channel here, so it is no radius, actual radius. So we need to calculate the hydraulic radius to fulfill this calculation. And to calculate the hydraulic radius, so the idea is cross-section area divided by the wetted parameter. So the cross-section area is 3 times 2. So this is not x, it is a multiply. So and then we could get the hydraulic radius is 0.75, and then we substitute in this equation, so we could get the flow rate is equal 27.422 meter cube per second. So and here, because our slope is 0.85 degree, we need to calculate the tangent of that angle. So this idea, if you see, refer back to our notes, previously we have a water channel here, a water flow with a certain inclination 0.85 degree. So according to the derivation of Manning equation, we will use the value of S is equal to tangent theta. So that's why when the slope is given in angle in 0.85 degree, so what you need to do is you need to calculate the value of tangent for 0.85 degree. So it is totally different with a slope with terms of 1 meter over 100. So if you have this term 1 meter over 100 means the height of open channel is reduced 1 meter when its length is 100 meters. So the angle here, so if you say 1 in 100, it will become 1 over 100, and this uh, calculation is actually refer to the tangent. Okay, so saya harap awak tidak melakukan kesilapan lah, kerana ada beberapa ketika pelajar dia hanya menggunakan 0.85 sahaja. Okay, next we are discussing the example number 5. So the trapezoidal channel as shown below is made of brickwork and slope at 1 to 500. 1. Determine the flow rate if the normal depth is 80 centimeters. Then determine the normal depth for which the flow rate will be 8 meter cube per second. And number 3, let the surface be clean earth which erodes if V exceed 1.5 meter per second. What is the maximum depth to avoid erosion? Okay, untuk soalan 1 dengan soalan 2, it's quite a straightforward question. So in question number 1, you need to calculate the flow rate at this when the normal depth is given. But in question number 2, you need to calculate the normal depth if the flow rate is given. So dia terbalikkan aja, so it's okay. And at the same time, you need to know how to use 1 to 500. Okay, you just make 1 over 500, jadikan dia pecahan aja, 1/500. And the idea of brickwork here is actually the roughness of that open channel. And for the question number 3 here, so the surface clean earth. So clean earth mean tanah biasa je lah. Okay. So persoalan dia, if the velocity is higher than 1.5 meter per second, so some sort of erosion will occur. So maknanya akan ada hakisan sekiranya had laju bergerak lebih daripada 1.5 meter. Jadi persoalan dia, kita nak apakah kedalaman yang maksimum supaya air boleh mengalir tanpa berlaku hakisan atau okay. Okay, this is answer for question number 1. So let's say the normal depth is 0.8 meter, the slope is 1 to 500, so it is equal to 0.002, and then the roughness for the brickwood is 0.015. So and then because the question asks about flow rate, so we use Manning equation to solve this problem. But the problem is, okay, this is just a straightforward, it's okay. So we have a trapezium here, okay, and then the y is given, and we need to calculate the flow rate. So the question is quite easy because all the dimension here is given. So what you need to do is you need to calculate the hydraulic radius. So this is the equation of hydraulic radius. So for trapezium, the equation for A and wetted parameter is given here. So you may remember this equation for trapezium. But if you cannot remember this one, or you don't know the equation to calculate the cross-section area and the wetted parameter for trapezium, it is okay for you to calculate one by one. So for example, you just calculate the area of rectangular here, add with the triangular area in left and right side. Okay, so that's please so it is advantage for you to use this equation. So and then we could get the hydraulic radius here equal to 0.5212 meters. We substitute in the equation, we could get that the flow rate it is about 5.23 meter cube per second. So this is the solution for question number 2. So question give you flow rates here 8 meter cube per second, and then they ask to calculate what is the normal depth. So again, we are using the Manning equation here, but the problem is the flow rate is given, but we need to calculate what is the value of y. So what we need to do is we expand the value, we expand the symbol of A or the equation for cross-sectional area here, and also the hydraulic radius. So, and then we substitute the value of slope, because the slope is given in terms of 1 to 500, means 1 meter reduction for 500 meters length. So it is okay for us just to use 0.002 square root. So, and then because it is too complicated, so I advise you to do the trial and error methods. You could use your calculator to calculate this one. So the cot theta and cosec theta can be replaced with numbers because the angle is given as 30 degree. So the cot here, you just replace with the value of a cot 30 degree and cosec 30 degree. So from the try and error, so inshallah, you will get the value of y equals 0.993 meter. So for question number 3, so they asked to calculate what is the maximum depth to make sure that the flow did not cause any erosion. So because the surface is clean earth, so we assume that the n is equal 0.02 and the maximum value is 1.5 meter per second. Okay. So because we want to make calculation about velocity here, so it is okay for you to calculate the value of q, means you start your calculation with the Manning equation, but if you alert the value of q here is equal to a times v, and then you could eliminate the influence of a. So now if you just use v equal 1 over n, and this equation might be your calculation is simpler because you don't need to calculate the value of a. So v is equal this equation, and we substitute the value of n and the substitute of slope here, and we already know that we are targeting to get velocity of 1.5 meter per second here. We use try and error method. So I mean, you could use your scientific calculator. I think one of our friends here reply comments in my YouTube and give link how to use equation in scientific calculator so that you could use your try and error method easily. So for example, if I substitute 1.1 meter, 1.0 meter, so the value is 1.48. So, and then I do some adjustment, increase the value of y, and then finally I could assume that when y is equal 1.025 meters, so the velocity will equal to 1.5 meter per second. So means that if you are doing civil engineering works, if you have an open channel, you just focus on the water level. If the water level is increasing more than 1.025 meters, so means that might be your open channel is start to erode.
Betul-betul?
Ya, saya.
Yang dekat surface clean earth tu value n dia 0.022. Dekat dalam V tu value n dia 0.002. Which one is correct?
Dalam sini.
Dalam bawah ni.
Yang
0.
Yang ini saya masuk 0.022.
Oh, dekat n bukan dekat
ni
surface tu.
n. Yang 0.002 ni slope S.
Ya, ya.
Okey, boleh nampak
Boleh.
Okey. So N ini akan diberi dalam table sebenarnya. Awak kena cari sendiri dalam table, tapi dalam peperiksaan saya akan beri dalam soalan teruslah. Okey, boleh
Boleh.
Okey.
Kalau table tu nak cari kat mana dah?
Kalau table
ada.
tu yang
Dalam doktor punya ni pun ada juga.
dalam nota kuliah saya ada, tapi
Ada.
sebenarnya kalau secara realiti kita akan ambil daripada experimental work, sebab open channel ni dia melibatkan kerja di luar, betul kan? Parit buatan, saliran. Jadi kita kata tidak semua parameter tu ada di makmal. Jadi selalunya orang akan buat sikit lah kajian. Tapi yang common type parit simen yang biasa, yang cantik, yang tak ada pokok tumbuh ke, tak ada apa pasir, apa mendak kat situ ke, selalunya dah ada lah dalam table. Okey, boleh Tapi selalunya dalam peperiksaan kita saya akan beri nilai tersebut. Maknanya insya-Allah lah pelajar tidak perlu untuk melihat table untuk menentukan nilai N. Okey, boleh ke?
Boleh.
Okey, boleh. Okey, so soalan ini kita dah fokus kepada soalan hydraulic jump. So maknanya kalau awak nampak soalan sebelum ini, maknanya untuk soalan 1, 2, 3, 4, 5 kita lebih kepada penggunaan Manning equation. Awak cari velocity, awak cari kadar alih, dan maknanya saya harap awak dapat pastikan kebolehan awak untuk menyelesaikan masalah trial and error tu. Okay, kerana pada saya dengan menggunakan scientific calculator awak masih lagi boleh buat pengiraan tersebut. Okay, now for example number 6 here, so we are calculating, we try to evaluate one phenomenon occur regarding to the open channel and energy changes which call the hydraulic jump. Okay, so let's say let's say we have this kind of dam. So and then when dam open its gate, open the slice gate here, so the water which is has potential energy here will flow through the slice gate here, and because the energy is higher, so it will push water to move faster. But as I said previously, might be it is not enough to calm down the water flow. So what happened, the energy will keep increasing, and then it's create the hydraulic jump here. So and then let's say we have at point number 1 here, so the height of water is 10 feet and the water flow here is around 2 feet per second. So and then by neglecting all losses, okay, all losses here is referred to major loss and minor loss that we learned previously. So we just assume that the outlet like this will not create any energy losses. Okay, so means the energy is keep in ideal conditions. But in open channel here, we cannot neglect the energy losses regarding to the existence of hydraulic jump. So that's why it's written here, except the dissipation in the jump. So when you have hydraulic jump, the energy loss. So the idea is, okay, I will use this one. Okay, kita memahami bahawa tenaga tidak boleh dimusnahkan dan tenaga dipindahkan daripada satu keadaan ke satu keadaan yang lain. Oleh itu kita boleh menulis mungkin commonly we could write as energy at inlet is equal to energy at outlet. Okay, but for open channel here, you must assume that at hydraulic jump there are losses, energy losses in hydraulic jump. So if we calculate, we think about the flow rate here. Okay, we could say that for point number 1 and point number 2 here, the energy is equal. Okay, however, so energy before and after the hydraulic jump is totally different. So means that you cannot equalize energy at 1 with energy at 3 because the hydraulic jump occur at the middle. So means that there are energy losses in hydraulic jump. So the total energy at 3 is not equal to 1 and 2. However, so the point here might be the point is different in level in uh, elevation. So but the total energy for 1 and 2 is equal. So I think this idea is already learned in fluid mechanics 1 about the Bernoulli equation. So I hope you could imagine this one. Okay, now the question asks to calculate the value of y2 and also the value of y3. So meaning we need to know what is the height of this one and what is the height at this position. Okay, let's say we simplified that diagram. So we have point number 1, we have point number 2, we have point number 3 here. As I mentioned previously, the hydraulic jump occur at this point. So the energy before and after hydraulic jump cannot be compared. However, we could compare the energy at this region because both of these points is located before the hydraulic jump. So we use the idea of energy at 1 must be equal to energy at 2. So we use the equation of y plus v squared over 2g. And this equation is actually comes from the Bernoulli equation. You know, Bernoulli equation is P over rho g plus v squared over 2g plus z. So because the atmospheric pressure is equal to 0, so we are calculating in gauge pressure. Okay, please make some revision about gauge pressure and absolute pressure. So we assume that in gauge pressure calculation, so the atmospheric pressure is equal to 0. So we could simplify the Bernoulli equation. So we just take v squared over 2g and we replace the term of z with y. So for 1, we have 1y plus v1 square over 2g, and for 2, we use the subscript of 2 here. So and then we substitute all the values. We know the location of the highest point at point number 1 here. So it is level of 10 feet and the velocity is 2. However, we do not know what is the value of velocity at point 2 and the height at point number 2. So it is okay for engineers. Once you have equation, you are lucky because by equation we solve the problem. So don't worry, one you could determine your equation here, so it's okay. So we could solve that problem. However, if you see this equation, we found that we have two unknown parameter, which is y2 and v2. So means that we need another equation to solve this problem simultaneously. So kita tahu, yes saya.
Kenapa G tu value dia 32?
Oh, silap. Oh, okay. Okay, sorry. Bukan silap.
Dia dalam feed.
Yeah. Okay. So first you see the unit here. So it is in British unit. So everything you could use, you could we could solve this problem, but we must this problem by using British unit. So the most common mistake
yang dekat G tu, yang dekat G bawah tu sama jugalah, cuma dah tak isi value lah.
Yang ni Y.
G.
Okay, yang G ni pun sama.
Okay.
So maknanya common mistake yang berlaku kalau anda kata soalan diberi dalam bentuk kaki, awak kena gunakan gravity dalam unit kaki per second square. So official value of gravity in a British unit is 32.2. So you use the same value here at this terms. Okay, untuk gravity ni pun awak guna yang sama. Kalau sebab kadang-kadang ada pelajar dia jawab lain, dia masukkan dalam kaki, gravity dia masuk 9.81. So nanti jawapan dia agak berbeza. So saya memang tak ubah soalan daripada kaki ke meter kerana ini adalah option subjek. Awak dah tahun 4, awak akan keluar sebagai engineer dan awak kena alert bahawa masih lagi digunakan unit British dalam mana-mana, dalam sebahagian daripada setting industri atau sebagainya. Yang paling mudah kalau awak nanti insyaAllah beli rumah, awak akan beli rumah berdasarkan square feet, lebar berapa kaki, panjang berapa kaki. Okay. Dan tanah mungkin awak pakai ekar, mungkin awak beli minyak di gasoline, di petrol station dalam unit liter. Okay, maknanya jaranglah orang nak beli minyak 0.07 meter padu. So gitulah. Okay, so boleh nampak So yang ini apa nama tu, saya harap awak dapat alert. So then okay, as I said here, we have two equations. We have two unknowns. So what we need to do is we need to produce another one equation so that we could do the simultaneous solution. So once we use the energy equation, so which is referred to Bernoulli equation, and the other equation that can be used to solve this problem is the continuity equation. So I think you already know the continuity equation. Q1 is equal Q2. So the equation is A1 V1 equal A2 V2. However, in a normal question in our syllabus, we will discuss in two-dimensional. So means that we only have X and Y without any width. So by assume that the width of our open channel here is constant because we know, for example, we have an open channel here. So it is here. So we assume that width is almost constant. So when width constant, so we have, let's say width is W. So we have W Y1 A1. So we have equal to W Y2 A2. And then we could eliminate the effect of width. So that's why in all this solution, the continuity equation is written as y1 v1 equal y2 v2 because we assume that the width here is constant. So we could eliminate the value. So we substitute the value. So it is a 10 and 2 here. And then we have, we rearrange this equation and then we label it as equation number 2. And then you know what to do. We have two equations and two unknowns parameter. So we'll, by using the idea of simultaneous solutions, so we could substitute one of them in another terms, and finally, we could get this equation. So fortunately, okay, so we cannot. It is not just a simple equation, so we need to use the try and error to get the value of y2 here. And according to the trial and error methods, so we could get that y2 is equal to 0.820 feet, and this depth will give the value of velocity at point number 2 is equal to 24.4 feet per second. Okay, so the main idea is by using the energy equation and the continuity equation, you do the you just derive the equation between point 1 and point 2 and then solve them, and you could get the value of y2 and v2. Okay, then how to get the depth after the hydraulic jump? As I said, the hydraulic jump will create losses, means the energy will reduce because there are losses in hydraulic jump. So means that we cannot use our common energy equation. Okay, in this case, okay, the energy equation cannot be used when you're discussing something before and after hydraulic jump, but the continuity equation can be used because we are discussing about incompressible flow. So the water density is constant, it's not changed. So mean that the volume of water is remain constant. So when the volume of water is remain constant, so means that whatever at inlet must be equal to whatever in outlet. Okay. So and then the equation that we could use to solve this problem is this one. So I hope you could remember this equation. So this equation is to actually it is a comparison between the height before the hydraulic jump and the height of water after the hydraulic jump. So what you could normally in text there are two versions written in textbook. Some textbook they will write -1 plus 1 8 fraud number 1 square root here, and I propose to you to remember you just replace the value of -1 at the front here to the back like this, because it is reduce the possibility for you to forget to mark to write the negative sign here. Okay, so the equation will become 2y2 over y1 equal, so in bracket 1 plus 8 fraud number 1 square with square root here minus 1. So point number 1 here is the location before the fraud number and before the hydraulic jump, and subscript number 2 here is referred to the location after the hydraulic jump. So you must remember that the fraud number here is referred to the fraud number before the hydraulic jump was occurred. Okay, so please remember this equation.
Doctor,
Yeah.
can we use continuity and energy question for this case?
Continuity boleh, tapi energy tak boleh. Sebab saya cakap tadi, kalau ada hydraulic jump tu seolah-olah losses. So maksudnya total energy before hydraulic jump dengan total energy after hydraulic jump tak sama. So awak boleh nak equalkan E1 sama dengan E2. Kalau dalam keadaan yang first tu, kejap. Kalau dalam keadaan yang first, walaupun satu tinggi, satu rendah dan sebagainya, dia masih lagi dua-dua point ini masih lagi sebelum hydraulic jump kan. So jadi kita boleh compare energy. Okay, apa awak nak cakap tadi?
So the hydraulic jump is not like a head loss, something like that.
Dia akan jadi head loss.
So why don't we just include the head loss into the equation?
Tak, dia boleh. Dekat akhir penyelesaian ni nanti saya akan beri awak head loss sebenarnya. Okay, ni cuma kita nak memperkenalkan normally dalam open channel orang akan guna rumus ni.
Oh, okay.
Okay, kalau awak nak kira head loss dia boleh, ada rumus dia. Awak hafal rumus head loss tu and then awak boleh buat energy equation macam biasa. Cuma kita saya nak tunjukkan kebiasaan maknanya kalau awak nak kira head loss, betul, boleh, tak jadi masalah. Tapi nanti kalau awak berbual dengan orang yang memang buat open channel dan sebagainya, mereka lebih prefer rumus ni. Jadi at least awak kena tahu jugalah rumus ni. Supaya at least, maksudnya knowledge awak tu, kita kata at least menyamai lah ataupun common yang kebanyakan orang dalam bidang open channel belajar. Okay, boleh Okay. So maksudnya yang ini rumus untuk kita mengira ratio ataupun comparison ketinggian before and after hydraulic jump. Okay, dalam kes ini kita dapati bahawa point number 3 is point after hydraulic jump and point number 2 is point before the hydraulic jump. So kita boleh masukkan equation itu akan menjadi seperti ini, and then we need to calculate what is the value of fraud number at point number 2, point where the hydraulic jump did not occur yet. So we substitute in this equation, we could get 4.75. And then we substitute in the equation, we could find that Y3 is equal 5.11 feet. Okay. So kita dah dapat ketinggian Y3. And then kalau awak baca balik soalan tu, dia akan kata ada kehilangan tenaga. So now we would like to discuss about the energy dissipation. Means that the energy loss. Okay. Now kita kata first We know that the energy at point 2 is 10.05 at 06 feet. So we could calculate it by using our previous data. So this is the total energy before the hydraulic jump. So and then, okay, we know that the equation for energy is remain the same. Okay, equation sama, nak cari energy before and after hydraulic jump sama. Cuma kita tak boleh equalizekan energy before equal to after hydraulic jump. Kita tak boleh nak samakan nilai. Equation tetap sama. So this is the equation to calculate the energy after the hydraulic jump. So and then the value of Y3 is already known, but the value of V3 is unknown. So kita kena cari. So jadi apa yang boleh kita cari ialah kita boleh menggunakan idea of flow rate, because we assume that water is incompressible, so mean the flow rate before and after hydraulic jump will remain the same. So in terms of volume, so means the volume is V1 Y1 V1 equal Y3 V3. We substitute everything, so means that if the height is Y3 here is 5.11 feet, so means that the velocity must be 3.912 feet. Okay, now we could calculate the energy at point number 3 by substituting the value of V3 here into the energy equation here. So and then we could get the energy equation is equal 5.348 feet.